of our drawing. Then now, okay, and then now we shall proceed to the analysis and design, the workflow majorly basing on robot structural analysis. That is what we shall cover today. And I so much welcome you. I'm so happy to have you here again. We're always very happy here at Rhodes Hub to have you and to be here with you. My name is Deograsha Sogwal. I'm a part of the Rhodes Hub team, welcoming you here again. And as we start off today's session, I would like us to share for some few minutes as well, majorly talking about where you're tuned in from today, where you're picking us from. And then also majorly, we talk about what you expect from today's class, especially those who were in class yesterday. What is it that you expect to add on from what we had built yesterday so that we can move on from there? Yes. Anyone to take us away?
Yes, good evening, guys.
Good
My name
evening.
is Bright. Yes, I'm joining you from Zimbabwe.
Okay.
So my expectation is just to learn how the software analyzes and designs some structural elements. Is I'm not really familiar with robot structural analysis. I'm used to designing using Tekla structural designer and Tekla TIDS.
Okay.
So I'm looking forward to the session. Thank you.
Thank you so much, Bright. Thank you so much for sharing with us. I know it's something new. Also, me, my first structural design software I used to use was Tekla Structural Designer. But yes, we keep on learning new things, and there we get to know which one does what better, things like that. So I'm so much happy to hear from you, or I want to hear from someone else as well. You tell us maybe if you attended yesterday's class, also what you picked from yesterday's class, because I remember we didn't have time to interact at the end of the session. Yes, anyone to take us away? Anyone? This is a free interactive session. Just feel free to unmute and you share with us.
Thank you. My name is Muhire Roger. I'm attending the session from Kigali, Rwanda, and I didn't have a chance to attend yesterday's session, but I'm looking forward for this session for the analysis and design stage and to the final results after modeling and getting all the details from the proposed structures. Looking forward to it being fruitful. Thank you.
Thank you so much, Rogers. Thank you so much for joining us. You need not to worry about missing yesterday's class. We have already shared the recording for yesterday's class. It's on YouTube, so you can actually go and check it out from the Rhodes Hub YouTube's channel, and you'll really have something good from there as well. Okay, let me hear from someone else.
Hello.
Hello, Mary.
My name is Mary. I'm watching from Zambia, and I managed to attend yesterday's class. I learned a lot yesterday, honestly. I got to learn more about the interface itself, the robot structure interface. That's my first time. It was my first time of using it. I've been using ProtaStructure and Procon, and
Okay.
today I'm looking forward to learning more on how some other people analyze, the way you go about analysis using robot. Thank you.
Thank you so much, Mary. Thank you for sharing with us and welcome you for today's session as well. You're most welcome. Okay. Anyone else to share with us?
Yes, good evening, everybody.
Good evening, John.
Yeah, my name is Gego John from Narok, Kenya. Yeah, so today I was able to attend. Yesterday I was able to attend the session, although I was a bit late. But today I had the opportunity to kind of go through the session which was recorded. So today I'm
Okay.
looking forward to how you come up, with the sizes of different elements, the structural elements, such as the columns, the beams, and the slabs, how you determine their sizes, and also the reinforcements to be used.
Okay.
Thank you.
Thank you so much, John. Thank you so much for joining us for today's class. Okay, let me hear from someone else. Your key takeaways from yesterday's class. I see Henry, your hand is up.
Yes, thank you so
Henry?
much for this opportunity. Yes, my name is Bagaya Henry and I'm joining in from Uganda. Yes, I managed to attend yesterday's session and I learned quite a lot as well because I've only used it for design of steel structures. And today I kind of expect to get to learn more about how best you can optimize the design so it is economical as well as means able to stand the loads that it is subjected to.
Okay. Thank you so much, Henry. Thank you for sharing with us. I'm sure your expectation will be met today. There's someone raising the hand with a device named Ghana. Okay, who could that be? Okay, just unmute and share with us. Anyone? Okay, I see he has dropped off. Anyone else to share with us? Majorly, your takeaways from yesterday's class about robot structure analysis. Then your expectations for today's class as well.
Hi.
Hello, Anna.
Hi, my name is Anna Zulu. I'm from Zambia and I enjoyed yesterday's session. It was very informative and I'm really looking forward to the analysis in robot as I've been using Procon for analysis. So I'm looking forward to seeing how another app is used to analyze a structure.
Okay. Thank you so much, Anna. Thank you so much for joining us again for today's class. We're happy to have you here and always part of the Roads Hub community. Okay, let me just hear from two more people and we begin our today's session. Yes, Kevin.
Hi everyone.
Hello, Kevin.
Good evening everyone.
Good evening.
My name is Kevin from Nairobi, Kenya. I'd like to share that I learned a lot from yesterday's class, but also to share that I am not a full engineer yet. I have a diploma in civil engineering and I'm aspiring to be a full engineer. I'll be very happy to share here in future that this platform made me learn and acquired skills that will one day make me a full engineer and someone that can also contribute to the built environment. I'm also asking if you can advise me or any other information that I can pick to move forward and learn as I aspire to be someone that can also be valuable in the construction industry. Thank you.
Okay. Thank you so much, Kevin, for sharing. I can guarantee you that you are the right where we shall be there to see you grow and we journey together as a team here at Roads Hub. We are so much happy to have you and just stick around and we shall see how best we can progress. Okay, let me get my very last person. Yes, someone? Anyone to share with us?
Well, I think for me, I would say yesterday was great, and though I wanted to look more into the preliminary sizing of the members, and then like beyond having a column pop up in the bedroom of the next floor, what do you consider when you are arranging the different columns and like the different structural members in a building? Thank you. That's my.
Okay. Thank you so much, boss, for sharing. And as our lead facilitator gets ready to take on, I'm sure we shall achieve all your expectations for today's class. And once again, this is Roads Hub, where we grow engineers, ultimate engineers, and of course, we're always happy to have you and to share with you with all the various aspects of engineering that we do offer and deliver. And just to give you a thumbs up, we always have a lot of trainings that go on every single time. We have the Revit structures training that is always here at Roads Hub. We have the road geometric design using Civil 3D. We have the urban drainage design class that is coming up. We have the site grading. We have AutoCAD for structural detailing. We have a lot of courses that we actually offer here at Roads Hub. So I would request and invite all of us to take and keep around and at least join one of these classes, because you will actually never regret joining them. The one that you feel like it is actually very important for you, I'm sure it will. I greatly advise you to join in for those classes, and trust me, you will have the very best experience here at Roads Hub. Thank you. Engineer Gatimo, are you in a position to take us away?
Hello, dear gracious. I hope you are well. Yes, I am.
Okay. As I welcome you, we have some very good expectations that I'm sure I have to bring to your attention so that you can, as we kick off today's class, you can see our best to meet them in the due course of the session. We have someone asking about how best to optimize design, then talking about the how best to go about with the analysis part of using robot structure analysis. Someone asked about how do you do the alignment of structural elements so that they don't affect the usability of the structure. Then many others, I'm sure you have also taken note of some. And with that, I would like to hand over the session to you. You're very much welcome. Engineer Gatim?
Hello, sorry, I was muted. I was talking to myself basically. So thank you, dear gracious, for sharing with us. Thank you for running the interactive session for us. I'd also like to thank everyone who has joined us today. It's always an honor to have you guys here with us, and it's always a pleasure to be part of your, of your learning journey and also part of your growth. So just to say, add on what, before I go into the modeling and answering the questions that have been raised, before I go into that, I'd just like to add on to what Deogratius has just shared. We have a few ongoing intakes for some of our courses in February. So if you'd like to register for any of them, you could just fill your name in the form that I've shared uh, via the via the chat box. That one is for RSA, but you could just fill it, and then we are going to get back to you, and we could assist you with selecting a course or the course of your choice. All right. So if you are interested in getting to learn, say, structural design in a more detailed or more structured way, just feel free to fill the form. And then you are going to reach out to you in the course of the week and guide you and also provide you with more information with regards to how the course has basically been structured. So apart from that, I'd really like to go on with what you were covering yesterday. We have a lot of ground to cover, and also this is the last day of our 2 day sprint, but you're going to have more sprints in the near future, and we are looking forward to learning and growing with you as well. So I'll just share my screen. I hope I'm audible. Let me share my screen, and then once my screen is visible, please type a one to let me know that I am audible and that you can see my screen, or you can see my presentation rather. Super. So I can see it is visible, and I hope I am clearly or I am audible. So this is what we have. So I'll just start with what say boss Wataba raised. So when you're starting or you're modeling your columns or when you're placing them, you have to work with the entire architectural file hand in hand. And the best way to do this is using CAD files because you can overlay them say in a software like Revit or AutoCAD. Overlay them together, and then as you place your columns, you can be able to tell that when I place a column at this point and I place it at this other point, they are not going to collide with the other architectural features or with the usage of the structure. So you're just going to want to avoid scenarios where you have a column going through a room. Probably it's at a wall or a beam intersection in the lower floors, and then in the upper floors it is passing through the center of a room. That is quite common, especially when you're working with the mansionettes. They are quite say complicated to do. But for these, say the normal residential buildings, they are usually a bit simple to do because their floor plans are say typical or they are just the same. They don't change much from floor to floor. All right. So just in the interest of time, I'm going to go directly into the software. We were able to cover quite a bit yesterday. So we were able to model. Sorry, let me remove these zone things. So we were able to model the first floor, okay? And we were remaining with modeling the staircase as well as now copying these elements to the other parts or to the other floors. All right. So I will start with modeling the staircase, and this one will be quite easy. So to model your staircase, this is all you have to do. First, you have to go to the axis definition. And the reason you're going to the axis definition is so that we can define an intermediary story between the base or between the ground floor and the story one. That's why we are going into the axis definition. So you're going to click on axis definition. Then you're going to go to the Z here. And at this point, you're going to add an intermediary story, right? So we're going to have the position as 0, the number of repeats as 1. And since our story height is 3 meters, the position of our landing will be 1.5 meters or just between the two floors. Then I'll click on add. Let me have number of repeats as 1, click on add, then apply. And once I do that, you're going to see that I have an intermediary story here. So I want to place this staircase in this point here. So I will use this grid 1 to model my landing. And then I will add another grid in this direction between grid 4 and 5 so that I can have a separation for both of my runs. That is the run coming from the ground floor, and then the run that is going to be moving from our landing to the second floor or to the first floor. So to do that, I will first measure this distance here so that I can see what you are working with. I'll go to tools. So to measure in robot, this is what you do. You go to tools, then you click on dimension lines. Then once you click on dimension lines, you just need to click between the 2 points that you want to measure and click outside. So I have 2.365. Not sure if what value I'll get once I divide this by 2. So let me do that quickly. 2.365 divided by 2 should equal something like almost 1.2 meters. So I will just define a grid here. I will go to grid 4. Okay. And then since this is in the x-axis, I will click on grid 4 to make it my current position. So you click on it to make it the current position. All right. Then once you click on it, you have the number of repeats as 1. And then I will enter the distance, 1.18. That's what I got. Then once I have that, I'll just click on add. And okay, I'll click on add, then apply, and then close. And then once I do that, you're going to notice that I have a new grid here. So by making this grid, it is going to make it easy for us to model our structure. So we're going to get started with that. I'm just going to go to my plan view here. All right. And then once I go to my plan view, I'm going to scroll down to my staircase level. All right. So remember, my staircase level is 1.5 meters from story 1. So when I use this button here, so this is the button we are using where you can see the XY, the story you're in, and then you have these 2 arrows here. So the first arrow takes you to the upper floor, and then the second arrow that is pointing downwards takes you to the lower floor. So you'll just use the lower arm to move to the lower floor, and then you are going to create a beam here. So I'm going to click on beam, and then I'm just going to define a new beam. I will define it as we did yesterday, and I will give this one a unique name, ST beam. And the reason I'm doing this is so that I do not load it with my walling. Okay, so the interest of having this beam is to just support our landing and not to support our walling. So I'll just have it in such a manner so that when I come to load my structure, I do not need to load this one with the walls. So I'll just have it here, then I'll click on add, then close. Then once I have that, I will place it between these 2 columns. And that one is the beam that is going to be supporting our landing at this point. Then after that, I will go to panels to define my floors. Okay, I'll go to my panels to define my floors. These are the risers or just the flights for the staircase. So I'll go to floors here. Then once I come here, I will define a new thickness. I will define a new thickness. I'll call it, say, the stair waist, just to be accurate. And then for the thickness, I will go with a thickness of 175 millimeters. The material I'm going to use, I'm going to stick with class 2530. Then I'll click on add and close. Then to draw it, you just select rectangle and then you place it. I hope you remember how you are placing them. You are staying consistent to the direction of modeling. You are working with left to right, then bottom. And you're going to see why we recommend you do that when we get to the analysis bit. Okay, so this is going to be my landing. When you go to the 3D view, you can see where your landing is. So what we need to do now is to model the risers. So doing this is quite easy, and you can do it in any way you want. So I will start with the one coming from the first floor going to the landing. Okay, the one that is coming from the first floor going downwards. So I'll just go to floors here. Then I will select my stair waist, ensure my model calculation method is shell. Then I will check rectangle. And then because this slab is not horizontal, it is slanting in height. Remember, it is moving from story 1 to the landing level. So I have to uncheck this horizontal slab. Then once I do this, I will click here, then click on this other support. And then instead of clicking at this point, I will just click on the drop down here and click here. Then once you do that, if you go to your 3D view, you can see your first landing there. So it's that easy to model, rather. It's that easy to model in robot. So I'll do the final one. I'll go to rectangle, have this one here, then move up to this level here and have my other landing there. So you can see I have my staircase ready. So once you have your staircase ready, now you can begin to do the other you can now replicate this model upwards. Okay, so replicating this model upward, it's quite easy. We said we have 3 stories, so all we need to do is copy this story twice upwards. Okay, and copying it is quite simple because all you have to do is go to the object inspector on the left. So to copy this structure upwards, you go to the object inspector on the left. So you're going to right click on the story parameter here. So I hope you can follow my cursor. I'm moving with my cursor to the left. And then just here under Object Inspector, we have stories. Then I'm going to right click on story. And then once I right click on story, I'm going to copy story. All right. So you just right click on story, then you place your cursor on stories, then you go to copy story. Then once you click on copy story, this pop-up is going to appear. And then what this pop-up is prompting you to do is just define the settings, say by which you want to copy your structure or your elements. So I want to copy them going upwards. So I will ensure geometry is at the top. And then the floor height is 3 meters. And then I will define the number. So I want 2 copies. So I'll just click on 2, and then I will click on OK. So when it comes to creating these copies, if they are just a small number, say 2 or 3, you can do it, say as I have done, copy all of them together. But if you are working on a larger story, say you want to create 5 copies, I'd recommend you do them, say 1 by 1 or in sets of 2, so that you do not overwhelm your software. All right, then I will uncheck this filter story axis so that you can see our structure. All right, and that is what we have. That's how you can visualize your structure within robot. And you can see, say, modeling it was quite easy. All right. So if you remember the design process we had yesterday, we had stated that after you've done your conceptual design, or you come up with a preliminary sizing of the members, this is where we are at. We have made, say, educated guesses on the, say, positioning of columns, their orientation, and their sizes. So in the next stage, we need to load the structure, load the elements. And then after we load the elements, we are going to do our manual combinations. And then we are going to run an analysis. And then after running the analysis, we are going to be able to understand how these loads are going to affect our structure in real life. Okay, so what are the shear forces that are going to arise due to our loading? What are the bending moments? What are the axial loads? And then once we have those results from the analysis, we are going to be able to design the structure or the elements in a more detailed manner and get the required, say, cross-sectional areas and also quantities of reinforcement. So at this point, we want to load our structure. And when it comes to loading the structure, we have the typical loads that you expect your structure to be exposed to, depending on where it is. So the most common ones are the dead loads, live loads, say construction loads, wind loads, earthquake loads, snow loads, and soil loads. And again, loads are hugely affected by where your structure is located. Okay, so for example, for the wind loads and the earthquake loads, see even the snow loads, they are majorly affected by the, say, geographical positioning of your structure. say there are areas where you expect to have more wind than others. There are areas that are seismic, others are not. So you need to cater for that. So if you are designing a seismic region, you need to understand you're designing a seismic region. And when you come to the software, you have to simulate those loads. Same case for the winds. If you are doing a structure, at least from where we are in Kenya, if you are doing a structure, say that is above 5 stories or 4 stories, you have to do your wind simulation and have those results catered for in the design. So for today's class, to keep it simple, we are going to majorly deal with the gravity loads, and those are the dead loads and the live loads. So majorly, dead loads are the say loads that you expect to be permanent on your structure, or they are going to be say more permanent on your structure. They include loads such as the self-weight, uh, loads or weights emanating from the finishes used on the structure. And then we have the live loads. The live loads are, I don't want to call them temporary, but they vary a lot as their structure is used during its design life. Okay, so in the day-to-day usage of your structure, your live loads are going to vary by a lot. Okay. You can view this by say when schools are open, you expect them to have many students, so your structure is going to be say fully loaded. And then when schools are closed, you do not expect the live loads to be on the higher end. And this one even applies to even the structures you are living in. Say for some people, if you're single, the area you're living in, it's going to have only one person moving around. But if you are married, if you have a large family, then there are more people moving around the structure, and also they are going to come with their own things, so they are going to have more loads. So the live loads, they vary by a lot. All right. So because of that, we are going to just design them, or we are going to load them. So when it comes to loading your structure in robot, it happens in 2 steps. All right, it happens in 2 steps. So the first step is defining the type of load, and then after you've defined the type of load, you define the magnitude. So the type is just the type. You tell the software that this is a self weight. You tell the software that these are loads, say, emanating from the walls. These are loads emanating from the finishes. And then, apart from that, now you have to define the magnitude. So after you've told the software I have wall loads, then you have to come and tell the software that this is the magnitude of my wall, or this is the magnitude of the load that is coming from my wall. So the first stage that you are in is in defining the type. So to define the type of loads, you go to loads here, then you click on load types. And then once you are here, you're going to see you have number one, and then the label, then you have the nature and the name. So the most important one is the nature and the name. So for ease of reference, the very first load that you're always going to define when working with the software is the self weight of the structure. Okay, the first load you always add, robot is going to automatically assign the self weight to it. So it's just good practice to assign this as the self weight, and then click on add. You can see once I did that, my structure became highlighted in red. So just to show you that these elements are the self-weights of these elements have been accounted for. Then you're going to have loads that you expect our structure to be exposed to. So we have the wall loads. So these are just dead loads that are going to be arising from the weight of the walls. Then we have floor finishes. And then I think from there I could move to live loads. So I'll change this to live. And then I will just have 2 live loads. I will have floor live loads and stair live loads. Just that. Then once I add them, I'll click on close. So at this point, we've told the software the type of loads that we that we expect. The next thing we need to do is to tell the software what are their magnitudes, what is the nature of the force, or how large or small is the force that is coming from these loads. So when it comes to loading the structure, I always recommend you decompose the loads manually so that you can be able to understand the loads better. Okay. And then the beauty of doing this manually is you can create a template like the one we have. You can create a template for your loads so that you can keep on reusing them. You do not need to keep on, say, calculating them every time you have the structure or you have a new structure, especially if they fall under the same category. So for the dead loads, I prefer if you say decompose them manually, and then for the live loads, we are always going to refer to the Eurocode and Eurocode 1 for the live loads. All right, so let's get started. I'll just make this quick so that you can save on time. Okay, so we have basic dead loads here, and this is just a way of, say, calculating for some of the loads that you expect to have. So for example, for the wall loads, you could easily calculate them by multiplying the unit weight of the material, that is the density of the material, say, of the blocks, the density of the clay pots that you're using as your walling material, then multiplying it by the wall thickness and the wall height. If you do that, you are going to get a load in kilonewtons per meter. Remember, the wall loads are going to be acting on the beam, or they are majorly going to be acting on the beam. So we expect them to be in kilonewtons per meter. So let's define this one. So to define it in the software, you do this. The first thing that you have to do is change the case here. I hope you can see where I'm moving with my cursor. Click on this drop down and change the cursor here to wall loads. Then once you change the cursor to wall loads, you just go to loads and then load definition. Then once you are at wall or at load definition, now you define the load. So these are the types of load definitions we can do. We can do nodes, we can do members, and we can do surfaces. So nodes are basically point loads. Nodes are basically point loads, and then members are majorly line loads, and then surfaces are loads that are acting on your panels or on your slabs, which are usually, say, area loads. So since the wall load is a line load that is going to be acting on our beams, we are going to select uniform load here. Okay, so you have various types of loads that you can add on your beams. You have the uniform loads, you have the uniformly varying loads, you have uniform moments, you have points and moments at given points. So just to say keep this simple, we are going to go with the uniform load. And then at this point, this is where you define the magnitude. So before I define the magnitude, I want you to take note of this. We have X, Y, and Z here. This one is really important. You take note of this, say, global axis coordinate system. I hope you can see it on my bottom left. So whatever this X, Y, and Z is what is here. Okay. So you can see X is in this direction, Y is in this direction, and then Z is going upwards. So the loads we are defining are gravity loads. And the sign convention for adding gravity loads in robot is that you have to include the negative sign so that you can tell the software my loads are acting downwards. So to include that load, you just have to come here to Z. It is acting in the Z axis from top to bottom. So because it's acting downwards, you start with a negative, then you add negative 10.2. So you're going to have negative 10.2 for your walls. Then you click on add. Then to select the members to be applied to, all you need to do is go to the object inspector, right click to select all beams, then click here and click here. And by simply doing that, once you click on apply, you're going to see that the load has been applied. Okay, it's that simple to do. So you're going to quickly add the others. You're going to quickly add the others. So after you have defined the wall loads, just go load by load. Next, do the floor finishes. So the floor finishes are going to be added to the, are going to be added to the panels. And for the floor finishes, I'm going to go with a load of negative 1.75 kilonewtons. So to do that, I will just go to load definition. And then once I go to load definition, I'm going to select surface here because these are loads that are going to be applied to the surface. Then once you click on surface, you're going to select the first load, uniform planar loads. I know there are a lot of types of loads that you can apply here, but for now we are going to focus on the uniform planar load. So click on uniform planar load, and then because this is a gravity load acting downwards, ensure the sign convention starts with negative. Ensure your load starts with a negative. If you do not do this, you're going to be telling the software that your load is acting upwards. And by doing that, you're going to get results that do not make sense. Okay, so always ensure that when you're defining gravity loads, you include the negative sign. So for this, I'll go with negative 1.75 and then click on add. And then I will select my floors. So just right click here on the floors, select all of them, then copy and paste them here. And then once you do that, click on apply and close. Then you have those loads added. So you have the loads from your, you have all the dead loads added. So you have your self weight, you have your wall loads, and you have your floor finishes. So with that, we have all the, say, we have the dead loads that we expect our structure to be exposed to. Okay. The next thing that I would want to define are the live loads. And values for the live loads, we majorly obtain them from the Eurocode 1991 Part 1. Okay. So for you to read these loads, you need first to go through table 6.1 so that you can understand the category under which your structure is. So you can see they are categorized from category A to category D. You have areas for domestic activities, you have office areas, you have areas where people may congregate, and you have shopping areas. So depending on the type of structure or the use of the structure, you are going to have varying loads. So the more people you expect your structure to serve, the more loads you have to account for. So you can see for us, ours is a residential house building, so we expect it to be under category A. So for category A, for the floors, we expect to have, say, loads of 1.5 to 2 kilonewtons per meter squared. For the floors, then for the staircase, we have 2 to 4 kilonewtons per meter squared. And then for the balconies, we have 2.5 to 4 kilonewtons per meter squared. So we are going to load these differently. We're going to do our floors first, then we're going to do our stairs. So we are going to go into robot. And then once we go into robot, we are going to select our floors and leave out the staircase. So to do that, you have to go into the object, to the member selection here. All right. So just follow my cursor. I'm hovering it say around or over my structure. Then I'm moving it to the member selection over here. You left click on member selection. And then once you do this, you're going to have these tools to select specific members. So this one is a very versatile tool that you can use to pick out any member that you want to use. So I will change this to panel, and then I will select my RC slab. So you can see this selection just selects my floors. It does not select my stairs. So I'll then copy these numbers. Then I will change my case here to floor live loads. And I will go to loads, then load definition. Then since this is a surface load, I will click on surface, then select surface load here. So we saw the area load for floors should range between 2 kilonewtons to what was that value? Once again, it was 1.5 to 2. So there's no harm in going with a negative 1.75 for that. So I'll click on add, then apply, and I will have my floor live loads added. Then I'll click on none here so that I unselect those floors. Then once I have that, I'll just close this and then change the case to stairs, live loads, all right? Then after I change the loads to stairs, live loads, I'll go to loads, then load definition. Then once I'm here, I'm going to change, or I'm going to go to surface and then select the surface here. And then by looking at the code, you can see that the imposed loads for staircase should be around 2 to 4 kilonewtons. So I'm just going to go with 2.5. I'll go with negative 2.5, and then I will click on, add. I'll click on add, and then once I come here, I'll just delete these. Then I will select my staircase here. I'll just select my stair waist here. Then once I select them, I will paste it. Then once you do that, you click on apply and close. And by doing that, you can see that you have easily just applied loads to your staircase. All right. Then after you've applied loads to your staircase, you need to create the combinations. Remember what I told you about robot? It is, say, organized in a very, I'd say, beautiful way, because it literally guides you on what you want to do. So you finished your geometry, then you've done your loads. So the software is telling you that you need to do your load types first, then you need to do your load definitions, and then you can do your combinations. And you can do your combinations in one of two ways, either manual or automatic. So with the manual combinations, you get to tell the software how you want your loads to be combined. And then with automatic combinations, you just let the software combine them for you. I always recommend you go with manual combination so that you can be in control. So go with manual combination. And then once you click on manual combination, you are going to get this prompt. So this prompt allows you to select the type of combination that you want or you need. So you have ULS and you have SLS majorly. So I'm going to be doing the ultimate limit state combination and the serviceability limit state combination for today. So for the ULS, I'm just going to give it a name, say ULS combination here. I'm just going to call it ULS combination and click on OK. Then once I do that, I just need to select all my loads and move them to this side. So you just click on these three dots, on this arrow, move them to the right, and the software is going to assign the correct factor. Remember what we said yesterday. When it comes to loading your structure, you expect some uncertainties in the design. So when it comes to loading the structure, sometimes you have to account for the scenarios where certain loads are going to be exceeded from time to time. So there are times the live loads may exceed what you actually designed for. Okay, probably the say masonry blocks that are going to be used to construct your wall, they are going to be heavier than you intended them to be. So for that particular case, you have to multiply them with a factor of safety so that you can just account for those, say, deviations. So this factor of safety is provided in the code. So if you are familiar with the Euro code, I know you know this factor 1.35 for the dead loads or for the permanent characteristic loads, and then you have the 1.5 for the QK or for the live loads. Okay, so we have that, and you can see that the factors are applied automatically depending on the type of combination you selected. So I'll click on apply to apply that. Then we are going to click on new to select or to create a new combination. So this time you are interested in selecting or in creating an SLS or a serviceability limit state combination. So I'll select SLS over here. And then in the combination name, for ease of reference, I'll call it SLS combination. And then I'll click on OK. So when it comes to selecting the case list or the loads to be used in the SLS combination, you have to be careful you do not include the ULS in the SLS. Okay, so you just press Control, select these first 5 loads, the individual ones, and then apply them. Don't have the ULS in this list here. So once you do this, you're going to notice the factor has been applied accurately. So it is just one. Then you click on apply and close, and you are good to go. So with that, you are able to easily apply your loads. Then this is something I always tell our participants. When you do your loading, it is always proper. You go to the load table and just see the loads that have been applied. Especially when you are new to the software, you might find that sometimes you leave out some loads or you make a few errors. So when you have finished, say, applying your loads, go to the load table, look at how your loads have been applied, ensure you have the negative, you have the negative symbol for them, and you also have the correct values. And then once you have this, again, just go through the combinations table and look at how they have been combined. So if you are not sure about what these 1, 2, 3 represent, they just represent these numbers here. So you can see our dead loads, self-weight, wall loads, and the flow loads, they are number 1, 2, and 3. So they are being multiplied by the factor 1.35. Then our live loads, cases 4 and 5, are being multiplied by 1.5 in the ULS combination. And then in the SLS, all loads are being multiplied by the factor 1. And that is what you expect. So with that, you are good to go now to analysis. All right. But before we go to analysis, there's something that I would want to talk about. So Robot is a finite element analysis software. And if you remember how finite element works, is it divides, say, all members into smaller, into smaller parts using nodes. Okay. And then it is going to analyze all the forces at all nodes and then extrapolate them to get the design, or also it will also calculate the forces at every node. So for you to design using robot, you have to ensure you set those finite element settings or the meshing settings correctly. Okay, it's a really, really important. Ghana, please stop writing on my screen. Please stop that. So for you to ensure that you get design right with robot, you have to ensure you mesh correctly. The first step when it comes to meshing, this is what we do. We go to tools, then we go to job preferences. So this is the first step that I will always recommend you take. Go to tools first, then you go to job preferences, and then you click on meshing, and where you have panels, you change this to user. And the reason I'm changing it to user is so that I can have more control over the software. I do not want it controlling my machine. I do not want it controlling everything in the background. I want to define my own parameters. So I'll always go with user. Then once you go with user, click on these 3 dots. Have them as complex mesh generation, and then go to method parameters and uncheck regular mesh. So these are just some of the tips that you use when working with robots, just to be in more control of how the software designs. All right. Then once you have this, just click on OK and OK. And that is the first step. Then the second one is in just is in now setting the machine to say to happen or to occur. So to create the machine or to break down our structure into the mesh elements, this is what we do. This is what we do, or this is how we do it. We go to this option here. It is called the options of finite mesh generation. So to break down the structure into finite element objects, we go into this option here called the options of finite mesh generation. So the first thing that you're going to do, we're going to use this one as the last one to generate the calculation model. So the first step is usually like the second one here. So you're going to click on panel calculation model. And then what this does, it just affects how the software breaks down the panels. All right. So I'm going to select all my floors. Then I'm going to copy their numbers, and I'm going to ensure that their panel calculation model is shell. And the reason I'm recommending you go with shell is so that robot can be able to uh, break them down into finite element members and be able to analyze and design for them. If you do not set them to shell, the software will use those panels for load distribution, but it will not consider them in the design. All right. So have them as shell, then click on apply and close. All right. Then once you have them as shell, go to options of finite mesh generation once again, and then go to meshing options. Apply this for all elements. And then once you do this, just set it correctly. We had done this before in the tools, so I'm just confirming if everything is as I had set. And then once we are good, I'll just click on OK, and we are good to go. Then once you have that, now you can generate the calculation model so that we can do our analysis. So you want to do your generation. You want to do your generation, just ensure everything is okay. And then once you do that, you're going to notice that the software breaks down everything into small elements. Okay, you can see our slab has been broken down. If you can see that, please type a 1. If you can see how our slab has been broken down, please type a 1. Super. I can see we are together. So we are going to proceed. So once you have these, once you have these, once you have this calculation model, now you can do your analysis. And analysis is quite easy, especially for the smaller structures. So to run this is simple. You just click on calculations here. So just click on calculations and let the calculations run. And then once the calculations have run, you're going to notice that the results are now available. Previously, the results were not available, but at this point, they are available now. So at this point, it means we can now get to understand how the various loads that we applied earlier on are affecting our structure. Okay, we can be able to see, say, the bending moments, the shear force, the axial loads, and everything else. We can be able to now read them from here. So I want us to do basically that. Get to understand the type of forces that have arisen due to the loadings that we applied. All right. But before we do that, let me open something here. Okay. I think this one is important to have. Okay, let me see. We'll expand this slowly. Okay, so I have that. So let me take you through how you read the results. So when it comes to reading the results in robot, it's quite easy. So we have tools in the software that allow us to read the results. So those tools are located in the results tab. They are located in the results tabs, and you can see they are we have many options. All right. And then as I proceed, I hope you are appreciating how the software has been organized. It's really easy to follow. You have your geometry, then you have your loads, you have your analysis, then you have your results, then you have your design. Like it's just arranged or organized to lead you on. All right. So we have our results. So for you to view your results, you have various options. We have diagram for members, we have maps on members, we have maps, and we have panel cards. And then we have these other options as tables. So for today, we are going to focus on diagram for members and also maps, right? So we are going to use diagram for members, and members are basically our framing system, that is our beams and our columns. And then we are going to use the maps for our slab. So at this point, what we are doing is getting to understand, say, the results or the effects of the loads that we anticipate our structure to be exposed to on our framing system. All right. So I want us to do that, and I want to show you what happens. So if you click on node here, and then if you click on say results, then you select diagram for members. This is the pop-up that appears. And this pop-up allows you to visualize the various stresses and also forces that your structure is going to be exposed to. So you have your normal forces, you have your tension, and you have your moments. So you have NTM, you have deformation, you have stresses, you have reactions, you have reinforcement if you've done your design, and then you have parameters. So the most important one for us at this point is the NTM and parameters. So parameters is just to allow us to visualize the results if we want to see them as labels and how we want the graphs to be seen. And then under NTM, it's where we can get to understand the individual forces or the individual stresses and internal forces that arise from our loads. So the FX is the axial load. And this is what I wanted to explain. Let me open up Paint in just a few. Okay, so this is how robot works. If you are looking at a member, be it a column, okay, so let's assume this is a column, or this is the longer section of a beam. This axis that is going to be cutting, the axis that is going to be cutting through this longitudinal section is the x-axis. Okay, this is the x-axis. The local axis, okay? This is the local axis for the members. And if this is the local axis, it means that if a force is acting in this direction, then it's an axial load, right? Then we have the cross section. We have the cross section right here. So let's assume this is the longitudinal section, and then this is a cross section. So you have these axes. We said for these members, you have the major axis that is going in this direction, and then you also have the minor axis going in this direction. So this axis in robot, the major axis or the axis along the deeper section is always Z. This is the local axis system for robots. So you have this axis as the Z, and then this axis as the Y. All right. So once you understand that, it becomes easier to understand these results. If you do not understand this, then you may not be able to understand what the software is communicating with you. So just to reiterate on that, this is the x-axis, and then this is the z, and then this is the y. All right. So from this, you can tell if this is the beam, and the Fz is going to be your shear forces. And that is what you are going to be looking at when you are designing for the stirrups or when you want to place your stirrups. Okay. And then if the forces are in this direction, then you expect them to cause a bit of torsion on your member. So that is mentioned, or it's just provided in some of the on the Autodesk forums. That's what I always recommend when you're using a software. Just make it a habit. Go through their forums, get to understand what they are saying over there. You get to learn a lot on how to use the software. So you can see the Fx is the axial force, the Fz is the shear, and then the Fy is the shear in the weaker axis. All right, you can also see it in this diagram here. So with that, now that we understand that, we can be able to just portray some of the results and show some of the results. I'll start with the FX, and the FX is particularly important when you're designing your columns, because for the columns, you're going to be designing for the axial loads and the moments. So I'm going to be having my FX here. And then once I show my FX, I'm going to go to my parameters. And parameters, we said it affects how the results are viewed. So I want to show labels, okay, so that they are a bit clear. And I want to show them the positive and negative values as differentiated. And then I want my graphs filled. So once I click on apply, you can see what happens. So when you have this, it becomes a bit difficult to read, right? It is a bit difficult to understand what is going, in the background. So to make this process a bit simple, or to make this a bit decluttered and easier to read and digest, I always recommend you filter them out. Okay, I always recommend you filter them out. So if you want to analyze your columns or just understand how your columns are behaving, go to the object inspector. Okay, go to the object inspector, right click to select all your columns. And then once all your columns are selected, click on edit in new window. Once you click on this, you're going to see your columns only. So to make these more, to make this a bit smaller or more detailed, just zoom in and click on normalize. Okay, you can zoom in, click on normalize, and then you can be able to see, you can be able to say make more sense of them. All right, so you have that. You can see in this view, they are a bit, say, decluttered. So what you want to look at this point is how these forces are behaving. So we said Fx is the axial force. And when you're looking at a column, you expect that the axial force or the load that it is carrying to cumulatively increase as it is going downwards. All right. So you expect for every column to have, to have the minimum loads at the top, and then for the axial forces, you expect to have the maximum axial forces at the bottom. And then these forces at the bottom are the one that you're going to use to design for your foundations. All right. So I'll just turn this to the ULS combination so that you can see this. So you can see that the maximum load that we have is 370 kilonewtons on the axial loads. So to know your maximum load, it's always painted in red. It's always highlighted in red. So this is the maximum load that our columns are facing. And then the minimum one or the smallest one is the 45.85 you can see here. Okay, so you can use this to just understand and judge if your modeling is correct. So if you come to look at this, then you find that for a column, say this column here, the actual load at the bottom is is smaller than the one at this second story level. Then you need to ask yourself, what is happening? Why is that happening? Okay, because it does not make sense. That should not be the case. All right, and then the beauty of this is you can filter out as many elements as you want. Say you are just interested in the ground floor columns. All right, you know that the most critical columns are in the ground floor. So if you want to just look at them, so you can expand your story one. Then once you expand your story one, you can select the columns in story one alone. Then click on Edit in New Window to view those parameters. And then you can zoom in and click on Normalize to make them a bit smaller. Or you can just click on Shift and page down on your keyboard to make them a bit easier to read. And you can be able to view your results better. So you can be able to even judge them on your own. And then something that you're going to notice that for the interior columns, they are always, or they're usually going to be experiencing more axial loads than the ones on the outer sides of the columns. So you can see the ones on the edges of the structure, the axial loads are in the ranges of 250 going downwards, and then all the ones that are inside the structures or on the inside, say on the inner part of the structure, they are all above 300 kilonewtons, which is something I'd say you expect. Then you may want to look at the moments, the MY and MZ, and something that you're going to realize is that most of the outer columns experience more bending as compared to the columns within the structure. And the reason is really simple, is because they support beams on one end and they do not support beams on the other end. So if you remember, say the Hody, the Hody distribution, the Hody method of distributing moments, you have a few elements that you are distributing moments here for. And then also in a realistic way, you have no element on the left side trying to counter out the moments. So this is something that you would want to look out for. and expect rather. So you expect your the columns on the outer edges to experience more bending and as compared to the movement to the columns on the inside part of the structure. And then you need to understand what these forces are. Okay, so we said Fx is the axial load, and then Fy and Fz are shears. So one is more along the major axis, and then Fz, and then the other one is along the major axis. And then Mx is the torsional moment. Mx is the torsional moment. So if you have this axis here and your structure is being rotated along this axis, then that is torsion because it is causing some twisting to your element. All right. And then after you have that, then you have your mx and my, and basically my and mz, and then basically those are bending along the major axis and the minor axis. Okay, so this is how you can easily view. And understand your results. This is how you can easily do that, just to get a good understanding of this. All right. So I'll show you something else. You may want to see the shear forces on the beams. So to do that, it's quite simple. I hope you can follow my cursor. Look at where I'm hovering with my cursor. Let me see if you're still following. I kind of lost my zoom thingy here. Okay. So we have this structure here. Follow with where I'm hovering with my cursor. So at the bottom, we have this 3D. So it is affecting this view. It is showing us a 3D view of our structure. So if you wanted to see the frames, you can work with XZ and YZ. So for example, if I went with YZ, okay, you can be able to see how the movements are distributed within the beams and the columns. Okay, you can be able to see that. So let me turn this to FZ. Okay, so that you can make more sense of it. So these are your beams and these are your columns. So for the shear forces, you expect your shear force to be maximum near the supports, and also say be almost zero towards the midpoint of your structure or of your members. And that is basically what you are seeing here. Okay, so that's how easy it is to view results for members. That's how easy it is to view results for members and just make sense of them. I always advise you go through them, ensure they are behaving in a manner that you expect. All right, and then that's how easy it is to do. Then the other thing that I would want to show you is the other method of viewing the results. And this one is basically for the floors. Okay, this one is basically for the floors. So you may want to see how the forces, the bending moments are carrying or they are distributed along your floor. And to do that, you need to go to results, okay, and then you select maps. And then once you select maps, it looks quite the same to what we had earlier. So you just need to select, what you want to see. So I'll bring you back to something I explained yesterday or what I was advocating for. During modeling, I was advocating that you stay consistent with the direction along which you model your slabs. If you choose to go from left to right, stick with that because the direction you start modeling with becomes your x-axis. And then the second one becomes your y-axis. So if you start from left to right, this becomes x and then this becomes to y. So it is always better if you stay consistent because all your panels will have the minor axis in the same direction. It becomes a bit hectic, okay? It becomes a bit hectic when you have this x-axis in this direction, and then when you came to this panel, your x-axis is in, do I know how to use this? Okay, so it becomes a bit hectic to read the results if the moments along X for this panel are in left to right, and then the moments for this one, X-axis are in this direction. It becomes a bit hectic to read. So the axis definition or the local axis for the panels in robots, the first direction you model is your X-axis, and then the second one is your Y-axis. All right. So with that, I think we can now just view the results. So I'll change this to the ULS combination, and then I will start with the XX so that you can just visualize, what we have. And basically this is what we have. Okay, so you can see the moments along the XX, say is the X direction. So you can see the moments are quite, they are quite small. They are quite small. And this here you have, and here you have, say, a map or a key. So the moments here are quite small. Our slab panels are not that large. So we are lucky enough. All right. And then you're going to notice that you have your moments here, the bending, they are going downwards, so they are negative. And then near the supports, you're going to have positive because they are going to be, say, acting upwards at this time. Or you're going to have some hogging moments at these supports, and that is something you expect. You expect maximum deflection near the centers, and then say zero deflection near or almost zero deflections near the supports, right? That's how you basically that's how you basically read your results. And then in the interest of time, I'd like to move to design so that we can have a good, we can have a good grasp of design, and then at least we can proceed from there next time. So we're going to design at least one member for each element. So we can do one slab, we can do one beam, we can do one column, and then we can do one foundation. Okay, so let's do that. So doing this is quite easy. At this point, a majority of the input is by the software. So when you ensure you've modeled correctly, this step becomes easy. So doing this, all you need to do is select, say, the floors. I want to design these floors only. I will do them for one panel, say for these floors on the ground floor only. So I'll select them from here. I will go to panel. I'll select the 150 millimeter slab. Then I will filter out the others so that I can only remain with one floor. And that's what you're going to use for design. So to design these elements, it's quite easy. All you need to do is go to design, then go with provided reinforcement for RC elements. You can see how say working with robot is easy. All you need to do is select the members you want to design. Okay, so I'll go to panel. I'll select my 150 millimeter RC floors. And then I not want to design for the entire structure. For the interest of time, I only want to design for the first floor only. So I will filter out the floors that I do not want to design for. And then once I do that, I'll just copy this list and then go to design provided reinforcement for RC elements. And then once you get here, this is majorly the template that is going to be used for design. And it's really easy to use. It is really easy to use. And you're just going to see how it works. So once you've brought your elements here, you're going to see your elements right here. So I only have one slab here. Let me go back and select correctly. I will do this in the plan view. Okay, let me do this in the plan view. Select these panels here so that I can I'm going to design provided reinforcement of RC elements. Okay, now I have the entire design here that I want to design for. So once I have these elements that I want to design for, the first thing that Ariel is going to do is set the parameters that guide your design. So robot is powerful in this way. It gives you a lot of power. You have to kind of set everything and remain in control of everything. Okay, so I'll start with the calculations options over here. And I'll just keep it simple at this point, just to take you through. And then we're going to proceed from there, or we're going to build on it slowly. So we have general, then we have concrete. You can see the concrete used in the calculation. So we have class 2530, and that is what we intended to use. So under reinforcement, we have to select the types of reinforcement we need. And for the design of slabs, we majorly use 8 millimeter bars, 10 millimeter bars, and 12 millimeter bars. But majorly they range between 8 to 12. And then wire fabrics, I would not need wire fabrics for this slab at this point. And then because it's not a flat slab, we do not need reinforcement for punching. So I will save these as calculation options for slabs. So I could call it calculation options for slabs, and then just have it there. So what I'm doing is just creating settings for the software so that we can use it for design as we intend to or as we want. So I'll just click on OK and OK. Then the second one is the story parameters, and this one majorly constraints the exposure class, or it is determined by the exposure class of the structure. So our structure falls under class S1, and at this point, we do not need to make any changes to this. So I'll just click on OK. Then the next one is the reinforcement pattern. This one is the important one for slabs. You have to ensure that under general, you have bars. Okay, you have to ensure that under general, you have bars. And then the maximum length of bars, ensure you use what is available on your sites. Ensure you use what is available on your sites. And then the minimum diameter, also work with what is available on your sites. And then once you have that, that's all you need to do. And then once you have that, just save this as let's have slabs reinforcement pattern and click on OK. And then click on OK here. And then once you do that, just click on calculate here so that the software calculates for you. All right. So you can see the software has calculated that for us. So I want to make this a bit simple to read. So I'll turn off a few things here so that it is easier to okay. Let me see. Okay, so this is what you have. You can see the the bars that you have and how they are spaced. So you can see this is the x negative direction. This is the x negative, and x negative is the bottom one bars in the x direction. This is the x direction, and then y negative are the bottom bars in the y direction, and then x positive are the top bars in the x direction, and y positive are the top bars in the y direction. So there you can see the coordinate system here. So you can just use them. Just know negative is bottom and positive is top. So when you look at a bar, you can be able to tell that this is the bottom bar in this direction, and then this one is the bottom bar in this direction. So it is placed in this direction, and then it is going to be arranged going upwards. And then you can switch between the other tabs just to see how the others have been arranged. And these are basically just the results. These are basically just the results for the design of slabs. So if you want to see the rebar, now you can go to RC design here, then select slab reinforcement. So it just follows what we did. So what was designed is this one that is ticked. Just click on calculate to show the reinforcement. Okay, so this is what I like about robot. It tries to sketch or create a sketch for you on how the rebars should be placed, and this makes your work a bit easy even when you go to detailing. I know I'm rushing a bit, but I hope you understand that I just have a lot to show you before the session ends. So basically, that's how you do them. I hope when you get the recording, you're going to be able to go over these more slow or at a slower pace, and as I appreciate the software more, right? So you have your slab there. And then if you want to generate the calculation note for the slabs, all you need to do is go to results, then click on calculation note and click on OK. Then once you do that, you're going to have your calculation note here. So you can compile this, and if you're taking your design for approval, you can include it in your you can include this in your approval. Okay, or in the document they're going to be taken for approval. Okay, so that's how you do the design of slabs. So I'll go next to the beams. And I always recommend you start designing the slabs, then you do your beams, then you do your columns, then you do your foundations. So slabs, then say the staircase, then the beams, then the columns, then the foundation, rather. So I'm going to design one of the beams here. I'm going to make it as easy as possible. And it's going to follow the same procedure that we used before. So to design it, you just need to select the beams that you want to design. And when you're selecting the beams, something I'd recommend is select them as continuous beam. So if you want to design these beams here, say along grid 3, remember they are going to be cast together, and rebars are not going to just enter this column here. They're going to be placed in a continuous manner. There's going to be lapping, and when bars don't need to be cut, don't cut them. So for you to account for that in the software, please ensure, or try as much as possible to design for them as a continuous beam. If you select one, robot will treat them as individual elements. Okay, so for robot, it basically does what you tell it to do. So you have that. Select that beam as one continuous beam. Then go to design. What did I do? Let me go back to geometry. Okay, so we go to design, then we go to provided reinforcement of RC elements. Okay, and then we'll go with manual combinations and click on OK. Then we have this structure over here. So once we have this, we can just select the reinforcement patterns that we had before, and then click on calculate. And then once you click on calculate, you are going to have your beams designed. Okay, I think the design phase is a bit easy as compared to the modeling and analysis bit. The important thing is just for you to understand what is happening at this stage, right? But just to give you an overview of what is happening, so when you need to design your beams, you need to first understand that you have to set the software. Okay, you need to set the story parameters. We did this for the slabs, so I'm just going to use the same story parameters because it is one structure. Then we have the calculation options, and these calculation options are what guide the software on how it is going to design for the individual elements. So you have your calculations options here. So you have general, then you can tell the software how you want deflections to be, to be corrected. Majorly for deflection, we want to correct it by depth, so we leave this as unchecked. And then for the minimum cover, for the beams, I think class 25 is just sufficient enough. So I'm going to leave them as class 25 and ensure that it is calculated to the edge of the transverse reinforcement or the stirrups. Then you have concrete here. So for concrete, we are working with class 2530, but I always recommend please design with the class that you're going to be using on site. When it comes to concrete, it's really important you design with the class that you're going to be using on site. Then we have the longitudinal reinforcement. And under longitudinal reinforcement, you select the bars that are available in your market. So if you are Kenyan, I don't expect you to select, say, 14 millimeter bars or the, say, 22, 24. We do not have those bars in our market. For us, we have 8, 10, 12, 16, 20, 25, 32, and upwards, you need to customize them. All right. And then the other thing is when it comes to selecting bars, I know my friends in Uganda and Rwanda, you use 460 MPa for your design. So ensure you change this to 460. So you just left click here and then you change this to 460 and click on OK. Remember, this affects the amount, the area of steel that you require. If you remember the formula for calculating the area of steel, it had moments as a numerator and it had the characteristic strength of steel in the denominator part of the equation. So if the characteristic strength of steel, if you use a larger value than what you need, you are going to end up with a lesser, with a lesser magnitude of the AS than you actually need. So for the characteristic strength, please always ensure you go with what you have on site. So again, I'll just change mine back to 500 and click on OK and close. And then for the transverse reinforcement, it's the same, but now I'll stick with 8 millimeter bars, and then I'll just save it as it is. Then I will go to now we have set the calculation options. Then next is the reinforcement pattern. And this is basically how you set how you want the bars to be placed. This one is really easy, and I won't be making any changes for it to it. And then once you're done, you can click on calculate to calculate, and you have your bars. So you can see your beam. This is where you see your beam. Then you can see your beam diagrams. So the first one is the bending moments. What you have in red are the maximum moments or the capacity of your beam. And then yellow is the design moments. And then green is the redistributed moments. So the check here is to always ensure that the design moments are always less than the capacity of the structure or of the section. And then you have your shear force here, so you can see how your shear force is behaving, and you have that, right? If you want to add another diagram, I like to add the one for deflection. So you just go to deflection here at the bottom, you check total and allowable, and you apply. And then you're going to get a deflections diagram. And then you have your deflections and what is allowable. So you always ensure that your total deflections are less than what is allowable. Then you have your beam reinforcement. This is your beam reinforcement here. And I like how it is shown in 3D so that it can aid in your design. And then finally, you have your beam load. Okay, you have your beam results. So you can see the number of bars that you need, how they have been placed, and also you have a simple material survey. So that's how you design beams. It's quite easy. It is quite easy to do. So next I will go to the design of columns so that we can finish designing our columns. And when it comes to designing our columns, I'll just give you how do I call this? Okay, I'll just give you an overview of how we design columns. So what I want to do is to select all the columns in the story one. So I'm going to be assuming you want to design columns in the story one. So we may not need to design for all of them, okay? We may not need to design for all of them. We can select a few columns that we want to design for, right? So we may say that for these interior columns here, we can design for the worst case scenario. And then for those columns that say are within the worst case scenario, we are going to assign them that particular section. And since it's the column we consider worst case scenario, then if we have a section that passes for that column and rebar, then it means that it is going to be safe for the other columns. So if you want to say identify the column that is, say, you'd consider your worst case scenario, you just use the tools, the results that we viewed earlier. You just check your fx and your my and get to see which column is experiencing the worst. All right, you can be able to see that. But you don't have to do this manually. You don't have to read them manually. What I recommend you do is select columns that you expect to behave in the same way. So for example, for these interior columns, you'd expect them to behave in the same way because we say the interior columns, they're likely to experience more axial loads and less moments, while the exterior columns are going to be experiencing majorly more moments and lesser axial loads as compared to the interior columns. So because I expect these exterior columns to behave in a similar way, so I'll just select all of them together. You left click on one of them, then you press Control and click on the others. Then once you do this, you just go to Design and you go to Provided Reinforcement of RC Elements. So give the software a minute and then click on OK to go into the design template. And then with this, you get a column that you're going to be designing for. So the design bit of columns, it's a bit easy because we have set the reinforcement patterns before. So all we need to do is select them. All we need to do is select them. Okay, all we need to do is select them and then run the calculation options. So when you use the software once or twice, once you've set everything, it becomes really easy to use. So we set the calculations option for the beams. It is almost basically the same thing. So we are not going to do that, just for the interest of time, so that you can get to explore other things. So when you design your column and it shows this green tick, it means it has passed the design. So at this point, you can be able to go through the results and then make your own judgment if it is, if it's okay for you, or if you want to increase the section, etc. So we have this column. It has passed the design. You can see the green tick on the left. So to view the results, you have this here, and these what you are seeing here. It's called the interactive diagram. On the x-axis or on the y-axis, you have the axial loads, and then on the x-axis, you have the moments. So why you have the axial loads, and then in the x-axis, you have your moments. All right. So what is in red here? It is basically a failure envelope. It is basically a failure envelope. So to put this into simple terms, when you design columns, you are considering majorly two factors. You are considering the axial loads and the moments. So you are going to be looking for a combination. You're going to be looking at the you're going to be looking at the effects of the combination you have in regards to the axial force and the moments. So since I think we can all read a graph. So if your combination falls within this failure envelope, your structure or your column is safe. If it falls outside, the software is going to alert you that your structure is failing. And if it falls outside, it basically means you need to increase the section of the column itself. So this one is more of a 2D interactive diagram, and then on the left you have a 3D interactive diagram. So you can see the MZ and the MY. So the beauty of using the software is this becomes a bit easy. When you have biaxial bending columns, it becomes a bit difficult to design manually. But once you have the software, it's a bit easier to design. And then the other thing that you may want to know is that anything above the x-axis, anything above this axis is a compression zone in the column. And then anything below the x-axis is tension. So this entire part here is just compression. And then this bottom part here is tension. I know someone may be asking why tension is quite small as compared to what we have in bending. And the reason for that is the reason we have the tension here is because the small one is because concrete is not good in tension, right? And then Wilfred, the yellow is just showing you where your combination falls. Okay, the yellow is just showing you where your combination falls. So we have that. Then we have the column reinforcement here. You can be able to see your column reinforcement. You can see we have, say, 40/20s for this column here. And then you have your calculation note. And it's basically, that I'd say that's easy to do. It's that easy to design for your columns, and you just follow the same procedure. Okay, so I want to design one footing so that at least by the end of these, training, you're going to have designed or have just basic exposure to the design of at least one element each, at least a slab, a beam, a column, and a footing. All right. So doing that, it's relatively easy. So what you do when it comes to the design of footings, it's basically very simple. You just highlight one of the nodes here. Okay. You just select one of the nodes here. Let me see. So I want to select this node. You just highlight it. Okay. And then once you highlight it, please note in the object inspector, you should only have one node selected. So you select one node in such a manner, and it's going to be highlighted here. Then once you do that, you're going to go to design and then provided reinforcement of RC elements. The software is smart enough to know that you want to place you want to design for a foundation at that particular point. And then at this point, you can already see that the software has given you a basic outline of how your footing would look like. All right. So I will just go to the options definition here. So for all elements, when you are using the software for the first time, you are going to have to set the calculation, the story parameters, the calculation options, the reinforcement patterns, and then for the soils, you're also going to set the type of soil and also the bearing capacity of the soil. So this is if you're using the software for the first time, but as you use it for the second time, the third time, these things become more of a template and you do not have to set them. For example, because I've been using the software for a while, I do not need to set anything, but just to demonstrate, I'm going to go through them. So I'm going to go to story parameters. At this point, you have already seen the exposure classes, so I'll just close that on. I think we are good with that. So for the story parameters, I will just select one from here. All right. Then I will go to calculation options. And then under calculation options, it is really simple here. Number one, under general, you don't need to make any changes. Then under concrete, you just need to look at the class of concrete being used. So for concrete, we are going to go with class 2530. It is really important you use the class that you're going to be casting with. So for the footings, I'm going to go with class 2530 and ensure that is what I have set. Then in the longitudinal reinforcement, I like to go with 500C. Then I will select the bars that I want. So I'll go with 12, 16, and 20. Then in the transverse reinforcement, I will go with the same size of bars. Let me change to 500C. I will go with 12, 16, and 20. Then in the additional reinforcement, I won't have any, so I'll just click on save and have these as a pad foundation calculation options. And then click on OK and OK there. Then I'll just close that. Then I will go to reinforcement patterns. So I don't need to make any changes here. I'll just select the first option. Then in the pyre, I will go with the third option. Then in the dowel, I won't make any changes. Then the shape, I will ensure for the main bars, my hooks are at 90 degrees. You know the type of hook we have just to cater for the development length. So I'll have them as 90 degrees. Then I will save this as foundation reinforcement pattern 2. Then click on OK and OK. Then after that, we have item dimensions. So if you want to enter the dimensions of your footing, you can change them from here. If you want to use, say, a concentric footing or an eccentric footing, if you want to design this type of footing or a combined footing, you can be able to select from here. All right. So I'm not going to be selecting the shape. I'm going to allow the software to do that for me. And then we also have the option to add additional loads. This one would come in handy when you are designing the foundation as a separate element. But because we have designed the structure, we have modeled the structure, run the analysis, so we have all the loads coming from the structure. So we do not need to define the loads. All right. Then the next one is the soil definition. So at this point, you're just defining you're going to be just defining the type of soil. Okay, so you can be able to select the type of soil here, the one you want to use. So I'll just stick with what is here, and then I will set the how do you call this? I will set the depth of excavation. So I'll just set it to negative 1.5, and then I will click on apply, and you're going to see that it has been applied. Okay, let me change it back to 0. Okay. Okay, so I'll just set this to 1.5 so that we can have so that we can account for. Okay, I'll just set the NA to negative 1.5 so that we can account for the depth of excavation, and we'll be good to go. So then once you click on apply, just save it as, give it a name. So I'll just call it, say, soils 1, and click on OK and close. Then the next thing is to now set the geotechnical options. And at this point, we are just going to set the bearing capacity. So for ease of design, I'm going to go with a bearing capacity of 250 kilonewtons per meter squared. So to set that, this one is in MPa. So I'll just divide that by 1,000, and I will end up with 0.25. Okay, so I'll just type 0.25 here as my MPa and save it as a geotechnical option. Then click on OK and OK. Then to design it, now I just have to set those things here. So we have the pad foundations we had set, the soils we had set, and then the story parameters. And then all you need to do is calculate. And then after you do that, you have your calculation and you have your fire as well. All right, so you can go through the results. You can see that the pressure acting on the soil is less than 0.25 on all corners of the footing. So you have 0.242 here, 0.229, 0.227, and 0.214. Then you have foundation reinforcement. You can view it there, and you can also view the stub column details from here. All right, you can look at the bars required, and also in the foundation view you can see in the foundations view you can see the dimensions of the footing required. So the software is telling you need a dimension of 1.1 by 1.1 by a depth of 0.25. And then to have your calculation note, I really like this one. It is quite detailed. So you can see your calculation note here and follow through it. And then the beauty of these calculation notes is that they have been referenced to the Eurocode at every point. So it is easy for you to follow through. And basically, that's how you get to design all elements within the software. And then I'll go back to geometry. And then I will just do this. Okay, so this is what I like. So when you are here, you're going to notice that if you want to see your footing, you can be able to see them from this view. So that if they are, if they are overlapping, you can be able to sort them out even before you go to detailing. And basically, that's how you use robots, and that's how easy it is to work with. All right, so that's all we had for you for the robot sprint. I hope you got to appreciate how the software is used. At least you've got to go through the whole workflow from working with architectural models to modeling in the software, to running the analysis, to designing, to viewing the calculation notes, and basically that's how robot works. All right. So thank you for joining us for this sprint. We really appreciate having you with us. And then just to mention, we have a few open, we have a few open intakes for our trainings for February. So if you'd like to join us, if you'd like to go through uh, structural design as a course, as a detailed course, we are going to be working on a 5-story structure that we are going to be designing for elements that we could not cover during the sprint. So we are going to be having elements such as ramps, basement walls, shear walls, uh, pad footings, combined footings, smart foundations, and many more, also roof structures. So you're going to be having that. So I'm going to leave the link to register in the chat box. Let me see if I can get it. So I've just shared the link in the chat box. There it is. So if you're interested, feel free to register for the course, and you're going to do right by you. We are going to ensure that we are going to ensure that you get value for your investment. All right. So again, I'll just leave a few minutes so that everyone can access the link. And if at any point you need any clarification, we're going to send the recording via email. Just respond to the email. If you need any clarifications, just respond to the email and we are going to sort you out. If you need to reach out to me or if you need to reach out to me, you could reach out to me via my number. I think I could give it out here. You could just text me on WhatsApp or text me on LinkedIn. So that is my personal number. And then my profile on LinkedIn, I think I go by Gatimu Ithaka. So you could get me there. So if you need to just reach out to me, you could do that. If you have any questions, just do that and we will respond to you. All right. So thank you once again. Have a good night and have a lovely weekend ahead.